So when we have symmetric data, we want to talk about the mean. Mean will be our idea of center. This time it's just value-based because we'll take into the actual calculation. So we calculate that x bar value. And then for spread, we want to use standard deviation, which standard deviation describes this average distance away from the mean. So this gives us an idea of how far data ventures away. So what we're going to do here is go through a pretty basic example, just simple numbers, keeping in mind this idea that we want to calculate this average distance away from the mean. So with this, we'll get an idea of how to calculate things by hand. Again, kind of like what we're going to do with the 5-number summary, we'll eventually rely on technology to do it for us. So what we're going to start with is our data set, just a 1, 2, 4, and 5. And what I'm going to do to the side here is just kind of draw a little picture to get what a plot looks like. So we have these values, and we have a data value at 1, a data value at 2, data value at 4, data value at 5. So we average distance away from the mean. So first thing we need to do is figure out what is the mean. So we'll calculate the average, which would mean adding our data together and dividing by the 4 values that we have. And this is going to give us a mean of 3. So with this, we can get an idea of just distance away from the mean. If our mean is here at 3, so I kind of imagine right here, there's our sample mean. Just getting an idea of how far each data value is away, that's called deviations. Just distance from the mean. And for this, we would take our data value. So for our data value x, and we're going to use a little subscript of I just to match the book, meaning like this is x1, x2, x3, x4. We could substitute numbers in for I to kind of denote where we are in the data set. And then what we want to do is take each data value minus our sample mean. So for example, we take our data value of 1, subtract our mean of 3, take our data value of 2, subtract our mean of 3, take our data value of 4, subtract mean of 3, and same thing for 5. So we get out these values, which are representing distance from the mean. However, negative and positive, which is showing like these two are below the mean, these are above the mean. But in terms of distance, this doesn't work for us. We need positive values, because what we should be showing is this data value of 1 is equally far away from the mean as this data value of 5. Both are a distance of 2 away. So with that, we need to take a step to get rid of negatives. If distances don't exist, we square them. So what we do is we look at the squared deviations. So instead of just the subtraction, where we take our data value minus the mean, now we square those values. So we're taking this 1 minus 3 and squaring it, 2 minus 3 being squared, 4 minus 3, 5 minus 3. So we're taking this negative 2 squared, so it's 4, 1, 1, and 4. And now we're getting through these values that have this kind of equal extremeness to them, where this is a 4 and this is a 4. That takes care of the fact that those are the same distance away from the mean. So we want to take an average. So averaging was the whole idea of add them up and divide by how many there are. So let's start with the numerator, where we're just adding up these squared deviations. I'm going to write out the long form way just so that we can start to see how the formula comes together. So we're adding up these squared deviations in the numerator. We'll talk about the denominator in a second. So in the numerator, we're adding up 4 plus 1 plus 1 plus 4, which will give us 10 in the numerator. So that's all good there. The denominator. So we take an average, we usually divide by how many there are, which we have 4 data values. That's our sample size. However, something happens when we take a standard deviation, and specifically a standard deviation from a sample. A little bit of error sneaks in. So what we have to use is something called degrees of freedom, which is just taking your sample size and subtracting 1 away from it. So we have a sample size of 4, take 1 away from it. So in that denominator, it's always the sample size minus 1. So really we're dividing by 3. So we have this value of 3.333. This number that we just calculated is called the variance. The notation for variance, if it's a sample, we use s squared. This different notation depending on where the values come from. So sample variance, or if we have population data, this is called sigma. So we have the sigma squared. This would be population variance. So that little symbol there is sigma. So variance is calculated, and you can see the formula added up. So remember, with our summation, we use our addition symbol here, and we added up all of these deviations squared. So taking the mean and squaring each one. So that's what we have. Summation symbol tells us to add between each of them. And then we take our data value minus the mean for each of those. And then divide by sample size minus 1. So this formula right here for our data set would be written out like this. And for us, our variance, we have a variance of 3.333. I'll actually take that to 4 decimal places just for a little more accuracy. So the thing about variance is it's squared. And that's going to make it hard for wording. Like if we think in terms of units, if these were measurements in inches, so our average would be 3 inches, this variance is talking about distance away from the mean, but it's squared. So we have this average distance away from the mean of 3.33 inches, and we don't want those units to be squared. So this is where we get to standard deviation down here, in that our next step is just to take the square root. If we have the variance, if you take the square root of it, that'll give us the standard deviation. So for that, with our notation where we have s squared and sigma squared, if we imagine taking the square root of these, we just have s and sigma, and this would be sample standard deviation. I'm just going to shorten that, and population standard deviation. So our formula is exactly the same as above. We have adding up those deviations squared over our sample size minus 1, but all we're doing now is putting a big square root over it. So for us, our standard deviation, we would take the square root of that 10/3, which is a 1.8257. This is nice because now this would have the same units as our mean. So if we were working with units of inches for those numbers 1, 2, 4, and 5, this would tell us that the mean is 3 inches, and on average, that deviates by 1.8257 inches. So it gives us this idea of where we're centered and how far away we expect to go. So if we bump up to that number line again, it's kind of like we get this average distance away. If I go 1 and then 0.82, 1 and 0.82, most of my data should be falling between those two values. This is kind of a small data set, so it's hard to see, but it gives us this average distance away where most of the values should be landing within that range there. So it gives us an idea of really where we expect to be, not only just middle value, but around it as well. Down here's the same notation that I wrote up above. It's just, now we can kind of see how it's all built together and how to calculate it. On this next page, I have an example. I'm going through the same process of calculating by hand. If you want to pause the video for a minute, then you can try it out and then check your answers as I go through it. So, they give us 10 heart rates here. They tell us the mean heart rate is 72. So we have this average of 72 coming through here. So first thing we want to find are just the deviations. So deviations, again, you take your data value minus the mean. So for each of these, we're doing this number minus 72. So 52 minus 72 is negative 20. 65 minus 72 is negative 7, so on and so forth. So you just fill out all of those deviations by subtracting away 72. Then what we want here are the squared deviations. So this would be a 400, 49. So this is where we should only be getting positive values out by squaring each of those deviations. What's nice about using this table format is now if we add up this column, if we add these up, that's the addition of all of our squared deviations. So if we throw those in the calculator, you're going to get 1016 out. And what that's going to do is that's going to find our numerator for us, for our variance and our standard deviation. So if we're calculating our variance, in the numerator, we add up the squared deviations, which would be that 1016, and then divide by, take our sample size, minus 1, which will be 112.89. Now for variance, we won't really put that into a sentence, just because, again, those units are squared, so it's like beats per minute squared and just doesn't quite work. But for our standard deviation, we can always make a sentence relating it to the mean. So for our standard deviation, we just take the square root of this calculation right here. So we have our square root, the addition of all those squared deviations over our sample size minus 1. And that's going to be a 10.62. So for making our sentence, you always want to state the mean. So we have the mean heart rate is 72 beats per minute. And this is our average deviation away from that mean. So, and on average, that deviates by 10.62 beats per minute. So real quickly, that gives us an idea of where we expect to land. We expect 72 beats per minute, but landing 10 below or 10 above is pretty likely as well. And that's how we calculate standard deviation by hand. Again, in those other videos, I'll show technology.